Hello students, this is part 2 dimensional analysis of units and measurement, which is the first chapter of 11th standard physics. This is mainly meant for competitive exams like NEET, IIT, KEAM, etc. based on NCERT syllabus, and for courses like CBSE and ICSE. We have already mentioned that in SI system of units there are 7 base quantities like length, which is represented by symbol M, and mass kilogram, time in seconds, electric current amperes, thermodynamic temperature K, and amount of substance in mole, and luminous intensity CD. All physical quantities represented by derived units can be expressed in terms of some combination of 7 fundamental base quantities of 7 dimensions. In dimensional analysis, actually the length can be shown in square bracket L and mass in square bracket M, electric current in square bracket A, and thermodynamic temperature in square brackets K, and amount of substance in square bracket mole, and luminous intensity in square bracket CD. This is how it is dimensionally represented. The base quantities are represented like this in dimensional analysis. Dimensions are the powers to which the fundamental units are raised to get the unit of physical quantity. The expression representing a physical quantity in terms of the powers of the fundamental units is known as the dimensional formula of that physical quantity. The equation obtained by equating the symbol of a physical quantity with its dimensional formula is called dimensional equation. Okay, so actually the dimensions are the powers of the dimensional formula. Uses of dimensions. The dimensions are used to check the correctness of a physical relation, or it is used to derive relationship between different physical quantities and to convert one system of unit into another. A general dimensional equation in a system can be written as Q is equal to M raised to A, L raised to A, T raised to C, A raised to D, K raised to E, mole raised to F, CD raised to G, where Q represents the dimension of the physical quantity, and M represents mass, L represents length, T represents time, A represents the electric current, K represents thermodynamic temperature Kelvin, and mole represents the amount of substance, and CD represents the luminous intensity candela. Here A, B, C, D, E, F, G are the dimensions of the base quantities, which are real numbers. It can be positive, negative, or zero, that represent the powers to which the fundamental dimensions are raised. Let's write some basic dimensional formula. Area, we know it is length into breadth, which means it is length into length, that is L square. That is the dimensional formula of area. Similarly, for volume, LBH, it is the product of 3 lengths, that means L raised to L cube. Okay, just like that, velocity or speed is equal to distance by time, that is L divided by T, which will give LT raised to minus 1. Acceleration is distance by time square, is L divided by T square, which will give LT raised to minus 2. Then force, we know that mass into acceleration, which is M into A, and M is a basic physical quantity, and acceleration, just now we have found out it is LT raised to minus 2, which will give MLT raised to minus 2. Work is force into distance, and we have just found out what force is. It is MLT raised to minus 2, in distance is L, which will give ML square T raised to minus 2. The expression which shows how and which of the base quantities represent the dimensions of physical quantity is called dimensional formula of the given physical quantity. For example, the dimensional formula of volume and velocities are L cube and L1 T raised to minus 1. Okay, you can write it as m0 L cube T0, m raised to 0 L cube T raised to 0 in square brackets, and for velocity you can write m raised to 0 L raised to 1 T raised to minus 1 respectively. An equation obtained by equating the physical quantity with its dimensional formula is called dimensional equation. Thus, the dimensional equation for volume will be V is equal to m raised to 0 L cube T raised to 0, and for velocity it will be V is equal to m raised to 0 L raised to 1 T raised to minus 1. Now let us see what are the applications of dimensional analysis. It can be used to derive a dimensional formula using the definition of a physical quantity in terms of the other physical quantities. So if we know the dimension of a physical, if you want to derive a dimension of physical quantity, based upon the definition of the physical quantity, we can join or connect, or maybe we can make different terms connecting those basic physical quantities, and we can make or derive a formula. Okay, and from that we can derive the dimensional formula. To check the dimensional consistency of an equation connecting different physical quantities, once it is formed, then we can check the dimensional consistency of the equation connecting different physical quantities. Dimensional consistency means actually if it's an equation, then if it's a equation with the multiple terms, okay, which can be added or subtracted, then actually each of the terms should have the same dimension. And if it is an equation, then both the sides, left hand side and right hand side of the equation should give the same dimensions. Thus only those physical quantities can be added or subtracted which have the same dimensions. Also, physical quantities represented by symbols on both sides of a mathematical equation must have the same dimensions. Let us see what are the rules of dimensions. Only those physical quantities can be added or subtracted which have the same dimension. That is the first rule. So in a dimensional equation, each term on both sides of the equal side or equality sign must have the same dimensions. The rule 2, a physical formula or equation will be dimensionally correct if the dimensions of all the terms occurring in both sides of the equation are the same. This is called principle of homogeneity. Okay, a physical formula or equation will be dimensionally correct. We will call it dimensionally correct only when the dimensions of all the terms occurring in both the sides of the equations are the same. This only means, by this we will confirm that the equation is dimensionally correct. This does not guarantee that the equation is correct, or it will not guarantee the correctness of the equation, since the magnitudes and constants are not considered here. If an equation has constants which are dimensionless, it cannot be verified by dimensional analysis. Let's check the principle of homogeneity of dimensions in detail. Though the magnitude of physical quantities may be added or subtracted from one another only if they have the same dimensions. If the dimensions of all the terms are not same, the equation is wrong. Okay. Dimensional consistency does not guarantee the correctness of the equation. It is uncertain to the extent the dimensionless quantities or functions. There are many terms in an equation where it contains trigonometric, logarithmic or exponential functions, or there can be ratio of similar physical quantities or pure numbers. These are all dimensionless, and the correctness of these expressions the dimensional analysis cannot guarantee. The dimensions of the fundamental quantities on two sides of a physical relation must be the same. That means if m1 raised to a, l1 raised to b, t1 raised to c is equal to m2 raised to x, l2 raised to y, t2 raised to z, this means that a should be equal to x and b should be equal to y and c should be equal to z. This means that only physical quantities of the same type can be added or subtracted. Now let us see some example. Find the dimensional formula of velocity and force. So how velocity, the dimensional formula we can find out for velocity and force. Velocity, we know that it is displacement by time. That is L divided by T, that L T raised to minus T. L T raised to minus 1. Okay. Now force is M into A, mass into acceleration, which is actually mass into displacement by time square, that is ml t raised to minus 2. Let's take another example, the distance traveled in time t. We know s is equal to ut plus half at square, where u is the initial velocity and a is the acceleration and s is the distance traveled. If you take the left hand side, the dimension of s is equal to L, and first time if you are taking, it is ut, it is velocity into time, it is distance by time into time. Again the dimension is L, and second time half at square, again the dimension we are getting distance by time square into time square, again it will be L. Okay, as each term on the right hand side of this equation has the same dimension of the left hand side, the equation is dimensionally correct. So the dimensionally correct equation may not be correct equation, but dimensionally incorrect equations are always wrong. Let's see one more example. The centripetal force acting on an object in uniform circular motion is given by F is equal to mv square by r, where m is the mass of the object, v is the velocity of the object, and r is the radius of the circular path. So in the left hand side, force is equal to m into a is mlt raised to minus 2. In the right hand side, mv square by r will give m into velocity square lt raised to minus 1 the whole square by L. Again it is actually mlt raised to minus 2. Since LHS is equal to RHS, the equations is dimensionally correct. The equation is dimensionally correct. Introducing relation among the physical quantities, obtaining equation of one physical quantity in terms of others. By knowing the dependence of the physical quantity on other quantities, being a product type of dependence. Okay. If one physical quantity is dependent on other physical quantities, being a product type, then we can make a relation on this. So if actually three physical quantities, for example, we will say a simple pendulum with a bob attached to a string oscillating under the force of gravity. This means t that means periods depends on the length, the gravity and mass of the bob. Then t is proportional to L raised to x into g raised to y into m raised to z. It is proportional to three quantities. So when we remove the proportionality constant, we can write t is equal to k into L raised to x, g raised to y, m raised to z, where k is the proportionality constant which is dimensionless. Now in the left hand side there is only t, therefore m raised to 0, L raised to 0 into t raised to 1. That is the dimensions of the left hand side with the time period. Right hand side, k we may not consider since it is dimensionless. Then L raised to x into g is the acceleration due to gravity, therefore it is Lt raised to minus 2, the whole raised to y. Then m is the mass, force, or m raised to z. So when you equate both sides, it will be z can be equated to 0 and minus 2y can be equated to 1, which means y is equal to minus half. Then x plus y is equal to 0, which means x is equal to half. Then we can write t is equal to k into L raised to half, g raised to minus half, m raised to 0, which is nothing but k into square root of L by g. Here the dimensionless constant k we can find out experimentally, which will be equal to 2 pi. This cannot be determined by this method. This does not distinguish between the physical quantities having same dimensions. So we cannot distinguish different physical quantities having the same dimensions using this method. We will now examine what are the limitations of dimensional formula. Since the magnitudes are not considered, we get dimensional formula on the basis of the physical quantities involved. Numerical constants have no dimensions. Hence, speed, velocity, instantaneous speed, change in velocity, change in speed, initial speed, final velocity all have the same dimensional formula. You cannot differentiate the physical quantity with the dimensional formula. All will have the same dimensional formula, LT raised to minus 1. In this method, we compare the powers of the fundamental quantities like M, L, and T to obtain a number of independent equations for finding the unknown powers. Since the total number of such equations cannot exceed the number of fundamental quantities, we cannot use this method to obtain the required relation if the quantity of interest depend upon more parameters than the number of fundamental quantities used. The third limitation is information about dimensionless constant cannot be obtained. This may be obtained by experiments or through complete mathematical derivation. Dimensional analysis cannot be used to derive relations involving trigonometrical, logarithmic or exponential functions as they are dimensionless. So in sin omega t or in e raised to minus kx, this omega t and kx are dimensionless. This method is not useful if the constant of proportionality is having dimensions. For example, in f is equal to g into m1 m2 by r square, the universal constant g is having a unit of Newton meter square kilogram raised to minus 2. Such equations cannot be obtained by dimensional analysis. Another example is the Planck's constant h. In more complicated situations, it is often not easy to find out the factors on which the physical quantity will depend. In such cases, one has to make guesses which may not be correct. This can also be used for obtaining a relation between two systems. So we know that the unit of work in SI systems is joule and in CGS system is ergs. So work is equal to force unit distance. Suppose the dimensions of work is equal to ml square t raised to minus 2. In SI system, we are considering meter in kilogram, mass in kilogram, length in meter and time in seconds. And CGS, mass in grams, which is 1/1000th of a kilogram, and length in centimeter, which is 1/100th of a meter, and time in seconds. So we can write it like this: ml square t raised to minus 2 is equal to 10 raised to 7 ml square t raised to minus 2. Because actually when we have to use in the CG system, we have to use actually 10 cube times of the mass. Then for meter we have to use 10 square times. Like so, we will get actually then we will get actually 10 raised to 7 ml square t raised to minus 2. That means SI unit of work is 10 raised to 7 CGS units of work. So 1 joule is equal to 10 raised to 7 x. Let us see how the dimensional formula are derived for the physical quantities. Let the first take length. Okay, the first one. First physical quantity we are taking length. Length we know it is very simple. Okay, it is length. Length is L, right? Length. It's a very simple one. Then area. Area we know that L square. Okay. Now volume. Volume is L cube. These are very simple dimensional formulas. Now let us see the fourth one is quantity of flow. Quantity of flow. Quantity of flow is volume by time. Volume by time. That is L cube by G. Okay. This L cube T raised to minus. Next one is mass flow rate. Mass flow rate is mass by time. That is m t raised to minus 7. When t is taken to the top, it will become t raised to minus 1. Okay. Sixth one is angle. Angle, we know it is a dimensionless quantity. Why? Because angle is arc length, okay, divided by radius. Therefore, two lengths, right? L by L, this is dimensionless. Okay, no dimensions. Now, next is 7 solid angle. Solid angle is the same. Solid angle has no dimensions. Why? Because it is area divided by r square. Okay, area is L square, r square is L square. So there is no dimension. 8. Eighth one is frequency. So frequency is equal to 1 by time period. Okay, that is t raised to minus 1. 9. Density. Density can be three types: volumetric density, then aerial mass density, and linear mass density. So when we say density, okay, it is volumetric, means mass by volume. Okay, that is m L raised to minus 3. M by L cube. Okay, volume is L into L into L. It is L cube. Now, aerial mass density is mass by area. That is m L raised to minus 2. Okay, area is L square. Then linear mass density is mass by length. Okay, that is m L raised to minus 1. Third one is velocity. Velocity. Velocity is actually displacement, okay, by time. Okay, displacement is nothing but length. Okay, by time is L t raised to minus 1. 13. Speed. Speed is same as velocity. Okay, it is also L t raised to minus 1. 14. Momentum. Momentum is equal to mass into velocity. It's equal to m L t raised to minus 1. Okay, we have velocity L t raised to minus 1, right? So mass to velocity to m L t raised to minus 1. Now 15 is impulse. What is impulse? Impulse is equal to force into time. Okay. Now what is force? Force is equal to mass into acceleration into time. And what is acceleration? Mass into distance by, okay, time square. Okay, into time. Okay, it's equal to m L by t square into t. Okay, that means one t will be cancelled. That is m L t raised to minus 1. Next is second moment of inertia. Second moment of inertia means it is the integral of distance square into dA. Okay, integral has no dimensions. The distance square means L square into A means L square again. That means L raised to 4. Dimensions L raised to 4. 17. 17 is actually acceleration. Acceleration already we have discussed here. Acceleration is distance by or displacement by time square. That means L t raised to minus 2. Then 18. 18 is force. Force is mass into acceleration is equal to m L t raised to minus 2. Okay. 19. 19 is centripetal acceleration. Again an acceleration. So it will be again same L t raised to minus 2. Centripetal acceleration. Is equal to, what is centripetal acceleration? Centripetal acceleration is equal to velocity square by radius. Okay. That is L t raised to minus 1 the whole square by r. Okay, is equal to L square t raised to minus 2 by L. Okay, one L will be cancelled, then L t raised to minus 2. Same as acceleration. Now we have, this is actually 20, 19 we are not considered here. 19 is actually centripetal force. So centripetal force. Okay, force means m into a. It is actually ml t raised to minus 2. Centripetal force, what is the formula? F is equal to mv square by r. Okay, F is equal to mv square by r. So it is m into L t raised to minus 1 v square by L. Okay, it will come m into L square t raised to minus 2 by L. That is ml t raised to minus 2, same as force. Okay. Next is 21, energy density. Okay. 21, energy density. What is energy density? Yeah, energy density. Energy density is energy by volume. Okay, energy by volume. Energy means force into distance. Okay, by volume. Force means we know that ml t raised to minus 2. Okay, means force is m into a. M into a means acceleration means distance by time square. Therefore, m into L t raised to minus 2 into L. Okay, divided by volume means L cube. Okay, so what you will get? 1 L will be cancelled here, so you will get square. So m L raised to 1 L raised to minus 2. Okay, this is when it goes up, it will be raised to minus 2. Then t raised to minus 2. That means m L raised to minus 1, t raised to minus 2. Okay. Now 22 is critical velocity. Okay. What's critical velocity? Critical velocity is Reynolds number. Okay. Reynolds number into F divided by A into velocity gradient. Velocity gradient, the whole divided by mass density into radius. Okay. What is this? Reynolds number, actually we will not consider Reynolds number since it is a number. Okay, it will not have any, it is not having any dimension. Therefore, we can ignore this. Then force, we know that mass into acceleration, that is ml t raised to minus 2. Okay, it will be a is L square, as we know. Then velocity gradient. Velocity gradient, what is velocity gradient? Velocity gradient, velocity by distance. So what is velocity? L t raised to minus 1. Distance is again L. Okay, the whole divided by mass density. Mass density means mass by volume. Okay, the ml raised to minus 3. Okay, into radius. Radius is again L. Okay, so this L and this L will get cancelled. Okay, so what we will get? M here actually L raised to 1, and you are having L square below, therefore m L raised to minus 1. Okay, plus 1 minus 2. Then here t raised to minus 2, then the t raised to minus 1 goes up because it is actually plus 1. So t raised to minus 2 plus 1 is minus 1 again. Okay, divided by m into L raised to minus 3 into L. It is actually m L raised to minus 2. This m and ml will get cancelled. So what you will get? L raised to minus 1, and this L square goes up, it is L square. So balance is L. Then t raised to minus 1. Nothing but velocity. Okay, L t raised to minus 1 is velocity. Next one is escape velocity. Okay, again 23. Escape velocity. Escape velocity is nothing but velocity, right? Escape velocity. So what should have been the formula? L t raised to minus 1. Let us see whether we are getting it or not. What is escape velocity? It is actually square root of rho g into r, where g is the acceleration due to gravity and r is the radius of earth. Okay, so root 2, okay, you don't have to consider root 2 since it's 2 is a number. It will not have any dimensions. So G means square root of G. G means L t raised to minus 1. Okay. Sorry, acceleration L t raised to minus 2. Distance by time square. Into R is L again. Okay. Therefore, you can consider L square t raised to minus 2. Okay. That means L square t raised to minus 2 square, the whole raised to half. Okay. It's since it's a square root. So what will you get actually? L t raised to minus 1. Again, it's a velocity. Next one is efficiency. 24. Efficiency is nothing but a ratio. Okay. Efficiency, eta will be always a ratio. So what will be whatever whatever quantity we have in the numerator, same will be in the denominator. Therefore, there will not be any dimensions, no dimensions. Okay. Now, 25 is gravitational constant. So we know that force is equal to G into m1 m2 by r square. Okay. Therefore, G is equal to F into r square divided by m1 m2. Okay. Is equal to F is, force is equal to m into a. So m a is L t raised to minus 2. Okay. R square is again L square. Okay. M1 m2 is mass square. Okay. So what you will get? You will get m raised to minus 1. Okay. M will go m raised to minus 1. Then L cube t raised to minus 2. We'll check. Okay. M raised to minus 1, L cube t raised to minus 2. It's correct. Next is Planck constant. 26. Planck constant. Planck's constant. What is Planck's constant? Energy by frequency. What is energy? Energy is force into distance. That is ml t raised to minus 2 into L. Okay. By frequency is 1 by t. This means m L square t raised to minus 2 into t raised to minus 1. Okay. What will be the result? M L square t raised to minus 3. That is Planck constant. Sorry, there is actually one mistake. This is not t raised to minus 1, t raised to plus 1. Okay, 1 by t raised to minus 1, when it goes up, it is t raised to plus 1. Then minus 2 and plus 1 will give minus 1. Okay, it is actually m L square t raised to minus 1. So let us see Planck constant m L square t raised to minus 1. Okay. Next is 27. Heat capacity. Heat capacity or entropy. Entropy. What's entropy? Entropy is heat energy by temperature. Okay. Heat energy by temperature. Okay. So energy is force in distance. So ml t raised to minus 2 into L divided by K. K is the temperature. Okay. That will give m L square t raised to minus 2 t raised to minus 1. Okay. This is the heat capacity or entropy. ml square t raised to minus 2 k raised to minus 1. Okay, it's correct. Next is specific heat capacity. 28. Specific heat capacity. What is specific heat capacity? Heat energy by mass into temperature. mass into temperature. Okay. So energy we know the force into distance is ml t raised to minus 2 into L. Okay. Divided by mass into temperature. Okay. Okay. That means m and m get cancels. Then L square t raised to minus 2 k raised to minus 1. L square t raised to minus 2 k raised to minus 1. Next is latent heat. 29 is latent heat. 29 latent heat. Latent heat. What is latent heat? Latent is heat energy by mass. That is m L square t raised to minus 2 divided by mass m. Okay, m and m get cancelled, then L square t raised to minus 2. Let us see whether latent is L square t raised to, yes, it is L square t raised to minus 2. Next is actually thermal expansion coefficient or thermal expansivity, 30. What is thermal expansion coefficient? Change in dimension by original dimension and temperature. Means change in dimension, let's say actually length. Okay, change in length divided by then original length into temperature. Okay, L and M get cancelled. That means k raised to minus 1. Now 31 is thermal conductivity. What is thermal conductivity? Thermal conductivity is heat energy okay, into thickness divided by area into temperature into time. Okay, what is this? This is actually thermal expansion coefficient. Sorry, this is actually thermal conductivity. So energy means m L square t raised to minus 2, thickness again L, okay, then divided by area is L square, then temperature is K. So this one will get cancels. Okay, so what we will get actually m L square and 1 L is here. Okay, again means this L and 1 will get cancelled. Only 1 L is there. ml t raised to minus 2 k raised to minus 1. So thermal conductivity is yeah, this is a small mistake that we forgot to add temperature here. Okay, that is not there. So it is actually t raised to minus 3. Okay, so it will be ml t raised to minus 3 and k raised to minus 1. Okay, that is thermal conductivity. This check here, thermal conductivity is ml t raised to minus 3 k raised to minus 1. Next is actually Boltzmann's constant, 32 Boltzmann constant. Okay, what is Boltzmann constant? It is equal to energy divided by area into time, okay, divided by temperature raised to 4. Okay, which means energy, we know what is energy, m L square t raised to minus 2 divided by area is L square into time, okay, into time and divided by k raised to 4, temperature raised to 4. Okay, that means L square get cancels, then m t raised to minus 3 t raised to minus 4. Boltzmann's question is m t raised to minus 3 k raised to minus 4. Correct. Okay. No. This is the Vn constant. Okay. 33 Vn constant. What's Vn constant? It is wavelength into temperature. Okay. That is wavelength is t raised to minus 1. Sorry, wavelength is length only. Length into k. Okay. Next is Boltzmann constant we have already discussed. Now universal gas constant 35 universal gas constant. Gas constant. Okay. What is universal gas constant? Universal gas constant is pressure into volume divided by mole into temperature. Okay. So pressure is actually force by area. Force is, you know, mlt raised to minus 2. By area is L square into volume is L cube. The whole divided by mole into temperature. Is equal to this L square and L cube will get cancelled. Then you will get 1 L left. That means m L square t raised to minus 2 mole raised to minus 1 k raised to minus 1. Okay. Let's see what we got. Universal gas constant is okay, m L square t raised to minus 2 k raised to minus 1 mole raised to minus 1. It is 36 work energy heat. Work energy heat. Polar energy. Work is equal to force into distance. That is ml t raised to minus 2 into s. That is m L square t raised to minus 2. Okay. Now 37 is kinetic energy. Again kinetic energy will be energy only. Therefore ml square t raised to minus 2. That is half mv square. Kinetic energy is half mv square. It's equal to half into m into v square is lt raised to minus 1 the whole square. Half we will not consider. So m L square t raised to minus 2. Again, same thing we are getting. Now 38 is potential energy. 38 potential energy is mgh. Okay. So m into g is acceleration due to gravity lt raised to minus 2. Okay. Into h is again height L. So it is m L square t raised to minus 2 again. Then 39 is pressure. Okay. Or stress. Pressure or stress. Okay. What is force by area? Okay. That is actually equal to ml t raised to minus 2 into L raised to minus 2. So m L raised to minus 1 t raised to minus 2. Okay. That is pressure or stress. Then 40 is electric energy density. Electric energy density. Okay, what is electric energy density? Electric energy density is energy by volume. Energy by volume. Okay, so energy we know that ml square t raised to minus 2. Okay, already we have seen that. Volume is L cube. So it is equal to L m L raised to minus 1 t raised to minus 2. Okay. M L raised to minus 1 t raised to minus 2. Okay. So next is 41. 41 is coefficient of viscosity. Coefficient of viscosity. What is coefficient of viscosity? It is force divided by area into velocity gradient. Okay. That force is ml raised to minus 2. Area is L square. Velocity gradient is velocity by distance. That is LT raised to minus 1 by L. Okay. So L and L get cancels here. And 1 L get cancelled from here. So what will get m L raised to minus 1 T raised to minus 1. This T raised to minus 1 goes up, it will be T raised to plus 1. So m L raised to minus 1 T raised to minus 1. Let us see what we get here. T raised to minus, okay, sorry. This LT raised to minus 1. Here below coefficient of viscosity mlt raised to minus 2 divided by L square LT raised to minus 1 by L. So this L get cancels, T raised to minus 1 is there. Then okay. Then is m L raised to minus 1 T raised to minus 1. Correct. It's correct. Okay. Okay. Next is stress 42. What is stress we already discussed. Okay. This force by area. Okay. We already discussed. Now next is modulus of elasticity 43. Modulus of elasticity is actually stress by strain. Okay. Stress by strain, stress, you know, stress is equal to force by area. Strain has no dimensions. So it is the same as stress only. Force by area only. That is m L T raised to minus 2 into L raised to minus 2. Okay. Therefore, m L raised to minus 1 T raised to minus 2. Same. Okay, so modulus of velocity is actually m L raised to minus 1 T raised to minus 2. Then bulk modulus. This is volume by volume into change in pressure divided by change in volume. V dP by dV. So bulk modulus 44 bulk modulus. Bulk modulus is equal to volume, okay, L cube into pressure. Change in pressure is actually we told m L raised to minus 1 T raised to minus 2. Okay, divided by change in volume. Volume is L cube. Again, it is same thing. We will get m L raised to minus 1 T raised to minus 2. The volume and volume get cancels. Okay, the same as modulus of elasticity. Now next is surface tension. Surface tension is surface tension. Surface tension 45. Surface tension is force by length. Okay, force by length. So m L T raised to minus 2 by L. That is m T raised to minus 2. 46 is surface energy. So it's nothing but an energy. Okay. So surface energy is actually surface energy by area. Okay, sorry. This energy by area. So energy, we know that m L square T raised to minus 2 by L square. So you will get m T raised to minus 2. Now let's see that kinematic viscosity 47. So 47 is kinematic viscosity. Okay, what is kinematic viscosity? Kinematic viscosity is force into distance. Okay, force and distance divided by area into velocity divided by density. Okay, that is force is ml raised to minus 2 into L. Okay, divided by area is L square into distance is again L. Sorry, area is L square and velocity is LT raised to minus 1. Okay, LT raised to minus 1. Then into density. Density is actually mass by volume, m L raised to minus 3. Okay, so this L square and this L and this L will get cancelled. So again this m and m will cancel. So you will get actually T raised to minus 2. Okay, then this T raised to minus 1 goes up. You will get actually T raised to plus 1. Okay, then you have L into L raised to minus 3. You will get L square at the top. So you will get L square T. L square T raised to minus 1. So let us see L square T raised to minus 1. Okay, that's okay. Now let us see 48. What is 48? 48 is strain. We know strain has no unit. It is a 48 is strain. Strain is actually length by length. So there's just no unit. Then 49. 49 is angle or angular displacement. You know, angle is equal to arc length, okay, divided by radius. So naturally L by L. So there is no dimension for that. 50 is power. Power means we know exactly power is work by time. Work by time. So work we know ml square T raised to minus 2 divided by T. So it will be m L square T raised to minus 3. Okay. Next is 51. 51 is rotational kinetic energy. Rotational kinetic energy. Rotational kinetic energy is equal to half into moment of inertia into angular velocity square. So half into half. So being a number, we will not consider that. So then moment of inertia, we know that ml square. Okay. Into ml square, then actually angular velocity is T raised to minus 1, you know, the whole square. So m L square T raised to minus 2. It is same as energy. See, rotational kinetic energy is again energy. ml square T raised to minus 1 is energy only. ml square T raised to minus 2 is energy. F into S is same. 52. 52 is torque. Torque is nothing but energy. Torque, moment, couple. It is same as work. Okay. So force into distance is equal to m L square T raised to minus 2. 53 torque. Torque we already discussed, same as energy. So it's m L square T raised to minus 2. Then 54. Surface tension we already discussed. Okay. Already discussed surface tension. It is force by length. So it is m T raised to minus 2. Surface tension. Then 55. Relative density. So relative density means it's a ratio of densities. Naturally, when two densities come in, it is dimensionless. 56. Refractive index. Refractive index is actually again a ratio. It's reflection again index is again a ratio. Okay, therefore it is actually again dimensionless. Refractive index. Okay. Is the ratio of velocity of light and velocity of light in the medium and velocity of light of vacuum. So it will be dimensionless. Then solid angle, we know, solid angle is actually arc by radius. It is again dimensionless. Then time period t is equal to t only. Okay. Frequency is equal to 1 by t is equal to t raised to minus 1. Then wavelength, okay, is nothing but distance length. Next is 61. 61 is intensity of wave. Okay. 61. 61 is intensity of wave. What is intensity of wave? Intensity of wave is actually energy divided by time divided by area. Okay. And energy is actually, we know, m L square T raised to minus 2 divided by time into area. Okay. So area will get cancelled, then m T raised to minus 3. Okay. Then again, 62 is angular speed. Angular speed or angular velocity is equal to omega is equal to theta by t. Okay. Is equal to angle by time. So t raised to minus 1. Then 63. 63 is angular frequency. Angular frequency. So we know angular frequency. Angular frequency is equal to 2 pi. F is equal to 1 by t. Okay, it is t raised to minus 1. 2 pi is a constant, therefore we will not consider for dimensions. 64. Hubble constant. Hubble constant. What is Hubble constant? It is a recession speed. Recession speed divided by distance. So speed is, we know, LT raised to minus 1 divided by distance L. So it is T raised to minus 1 again. L and L will get cancelled. So 65 is intensity of wave. Intensity of wave. So we already discussed that intensity of wave and we received. So 68 is angular momentum. Okay. 68. 68 is angular momentum. Is equal to moment of inertia into and angular velocity. Okay, moment of inertia is, we know actually what the moment of inertia is equal to mass of the radius of gyration, so ml square into omega is equal to t raised to minus 1. So it is ml square t raised to minus 1. Okay. 69. 69 is radius of gyration. We know radius of gyration is distance only. Okay. L. So it is L only. Radius of gyration. So 70. 70 is moment of inertia. Just now we told actually mass into radius of gyration, the whole square. Okay. So m L square. That is moment of inertia. 91. Sorry, not 91, 71. 71 is moment of inertia. Then one we left actually 70 we left. This is actually moment of inertia 71. 70 is angular impulse. Angular impulse. What's angular impulse? Torque into time. Torque into time. Torque we know ml square t raised to minus 2 because since it is energy into time. So it is ml square t raised to minus 1. Okay. So 70 is ml square t raised to minus 1. Then next important one is actually 72. 72 is nothing but current. So current is the basic physical quantity. It is ampere. Okay. Then 73 is charge. Charge is equal to I into T. Okay. So it is A T. Then 74. 74 is current density. Current density. What is current density? Current density is equal to current divided by area. So A L raised to minus 2. Okay. Now 75. 75 is potential difference or voltage, then electric potential. All these are the same. So what is voltage or potential difference? Okay, it is actually work done divided by charge. What is work done? We know that ml square t raised to minus 2. Minus 2. Charge is actually, we know, I into T. Okay, I into T means A T. So we will get m L square, okay, ml square t raised to minus 1, a raised to minus 1. So it is not t minus 1, this is my t raised to minus 2 is there. Then when this t goes to the top, this t raised to minus 1 again, therefore it is t raised to minus 3. So voltage is ml square t raised to minus 3, a raised to minus 1. Now, next is actually 78. 78 is resistance. What is resistance? Resistance is R is equal to B by I. Okay. So what is V? Already we just know we have found m L square t raised to minus 3, a raised to minus 1. Okay. Divided by A. Okay, V by I. I is again A. So it is m L square t raised to minus 1 minus 3, a raised to minus 2. Okay. Resistance is now electrical resistivity 79. 79 is electrical resistivity. What's electrical resistivity? Rho electrical resistivity, rho electrical conductivity is equal to R A by L. L. Okay. So R we know just now we found out ml square t raised to minus 3, a raised to minus 2. Okay. Into L square. Okay. A means area. L is again length. Okay. So it is m L square L raised to 4 divided by L ml square t raised to minus 3, a raised to minus 2. Let's check. ml cube t raised to minus 3, a raised to minus 2. Correct. Now next is capacitance. 80 is capacitance. What is capacitance? Is equal to Q by V. Q is equal to I into T. 80. V. V we know. Already we have found out V. V is actually m L square t raised to minus 3, a raised to minus 1. Okay. Already we found out. T. You see, you can check here. V here. M L square t raised to minus 3, a raised to minus 1. Okay. So capacitance m raised to minus 2 raised to 4 a square. Okay, correct. Minus 1, L raised to minus 2. 81. Inductance. Inductance is equal to, we know that actually V is equal to L dI by dt. Okay, which implies L is equal to V by di by dt. So V actually, we already discussed it. P is m L square t raised to minus 3 a raised to minus 1. By dA by dt means a by t, t is t raised to minus 1. So it will be m L square t raised to minus 1. When goes up, it will be t raised to plus 1. So t raised to minus 2 into a raised to minus 1. Then again a will go up, it will be a raised to minus 1 again. So a raised to minus 2. Okay. So inductance will be ml square t raised to minus 2 a raised to minus 2. Then 82 is differentiation. Differentiation is not dimension. And again permittivity, free space. Then permittivity epsilon 0. Okay. We know that f is equal to 1 by 4 pi epsilon 0 q1 q2 by r square. So epsilon 0 is equal to 1 by 4 pi f into q1 q2 by r square. So 1 by 4 pi you don't have to consider here since it is a constant. F is equal to 4 is actually ml t raised to minus 2. Okay. Into q1 q2 is will mean it. Okay. The whole square divided by L square. So it will give a square t square then divided by m L cube t raised to minus 2. So it will come m raised to minus 1 then L raised to minus 3 t raised to 4 a square. So m raised to minus 1, L raised to minus 3, t raised to 4 a square. Okay, correct. Now next is permeability of free space, 84. Okay, mu 0. So we know that c0 velocity of light is equal to 1 by square root of mu 0 epsilon 0. Okay, so for c square is equal to 1 by mu 0 epsilon 0. So which implies mu 0 is equal to, okay, mu 0 is equal to 1 by epsilon 0 into c square is equal to 1 by epsilon 0. We just now we got m raised to minus 1, L raised to minus 3, t raised to 4 a square. Okay, into c square is equal to velocity. Velocity is lt raised to minus 1 the whole square. Okay, so it will be 1 by m raised to minus 1, L raised to minus 3 and L square will give L raised to minus 1. Okay, L square and L raised to minus 3 L square. Then t raised to 4 and t raised to minus 4 will give t square then a square. So it will be m L t raised to minus 2 a raised to minus 2. So ml t raised to minus 2 a raised to minus 2 is correct. Okay, this is the dimension of permeability. Next is refractive index, 85. refractive index is a ratio. This is a, what is refractive index? Speed of light, okay, in vacuum divided by speed of light in medium, okay. So refractive index is actually, so epsilon 0 by r, okay. So we will get actually, this is, since it's the ratio, there is no dimension. Okay, now 86 is Faraday constant. Faraday constant. So Faraday constant is actually Avogadro constant, Avogadro number into elementary charge. Okay, the charge is equal to A into T, IT. So IT divided by IT per mole. Okay, mole. So it is actually 80 mole raised to minus 1. Okay. Now 86. 86 is, yeah, 8 is Faraday's constant. Now 87. 87 is wave number. What is wave number? Wave number is equal to 2 pi by wavelength. Okay, wavelength. Wavelength is L. So it is actually L raised to minus 1. 2 pi we will not consider since it's a constant. Now 88. 88 is actually radiant flux or radiant power. Okay, radiant flux, radiant power. Okay, radiant power. What is this? It's equal to energy emitted per time. Energy per time. Energy we know that ml square t raised to minus 2 by times C is actually ml square t raised to minus 3. Okay. Now um, 89. 89 is luminosity. Luminosity of radiant flux. Okay. Or radiant intensity. What is that? Radiant power. Or radiant. Okay, radiant power divided by solid angle. So radiant power already, or radiant flux we have just now derived ml square t raised to minus 3, and solid angle has no diameter, therefore it will be ml square t raised to minus 3 itself. Okay. Then 90 is equal to luminous power. What is luminous power? Luminous energy emitted per time. So luminous energy by time. So the energy, we know what is energy? ml square t raised to minus 2 divided by time. Okay, it's equal to ml square t raised to minus 3. Okay, again. Then 91. 91 is luminous intensity. Okay, what is luminous intensity? Luminous flux. Luminous flux by solid angle. So luminous flux we know ml square t raised to minus 3. This now we have removed. Okay, we actually found out luminous flux is ml square T raised to minus 3, and solid angle has no dimension, therefore it will ml square T raised to minus 3. 92. Illumination or luminance, intensity of illumination. Okay, luminance. Luminance. What is luminance? Luminance intensity by distance square. Okay. Luminance intensity, just now we have derived here, ml square T raised to minus 3. Okay, divided by distance square. Distance square is L square again. So it will be m T raised to minus 3. L square will get cancelled. M T raised to minus 3. Now relative luminosity. 93 is relative luminosity. What is relative luminosity? Luminous flux by luminous. Okay. Relative luminosity means it's a ratio of the same quantity. Imagine luminous flux by luminous flux only. Okay. Luminous flux of a source of given wavelength by luminous flux. So it's a ratio of two luminous fluxes. Therefore, it is dimensionless. It is dimensionless, no dimension. Okay. Now 94. 94 is luminous efficiency. Luminous efficiency. So luminous efficiency is again a ratio, okay, of actually total luminous flux by total radiant flux. Two fluxes. Therefore, it is dimensionless again. Okay, dimensionless. Now 95. 95 is illumination. Sorry, illuminance or illumination. Okay, this is actually illuminance. What is illuminance? Illuminance is actually luminous flux divided by area. Luminous flux incident divided by area. So luminous flux actually already we have calculated m L square T raised to minus 3 divided by area. Area is equal to L square. It's equal to m T raised to minus 3. Okay. L square will get cancelled. Then 96. 96 is actually mass defect. Mass defect. Mass defect is a sum of masses of nucleons. Okay. Sum of masses of nucleons minus mass of the nucleus. That means it is a difference in masses. Okay, that means the dimension is m. 97. Binding energy of nucleus. Binding energy. Okay, energy. Binding energy of nucleus. Binding energy of nucleus is actually nothing but the energy. What is energy? It should be ml square T raised to minus 2. Okay, let us see whether we are getting this ml square T raised to minus 2 or not. So it is actually mass defect into speed of light in vacuum square. Speed of light square. Okay, mass defect is m only. Speed of light is actually LT raised to minus 1 the whole square is equal to m L square T raised to minus 2. Okay, is correct again. Okay, it is energy only. Again 98. 98 is the decay constant. a constant. It is actually 0.693 into half-life. Okay, half-life. Half-life is nothing but time. So 0.693 is a constant. Therefore, 1 by t, that means t raised to minus 1. 99. 99 is actually resonant frequency. Resonant frequency is equal to, resonant frequency is 1 by root LC. So we know what is L and what is C. Okay, what is L? L is equal to 1 by square root of okay, 1 by square root of M. L is ml square t square a raised to minus 2 into m raised to minus 1 L raised to minus 2 t raised to 4 a square. Okay, so what you will get is equal to m and m raised to minus 1 will get cancelled. L square and L raised to minus 2 will get cancelled. Okay, then a raised to minus 2 a square will get cancelled. Then t raised to, this is t raised to minus 2. T raised to minus 2 and t raised to 4, that will have actually 1 by square root of t square only is left actually. That means 1 by t. Okay, it is t raised to minus 1. That will be t raised to minus 1. Okay. Now 100. That is 100. 100 is Q factor. 100 is quality factor. Q factor. What is quality factor? Quality factor is actually resonant frequency. Okay, resonant frequency, then into inductance. Okay, divided by resistance. Okay, so resonant frequency we know that t raised to minus 1, and inductance is ml square t raised to minus 2, then a raised to minus 2. Then divided by resistance. Resistance is m L square t raised to minus 3 a raised to minus 2. Okay, so m and m will get cancelled. T raised to minus 3, then a raised to minus 2 will get cancelled, then t raised to minus 3 into t raised to minus 1 here, it will get raised to minus 3, then all the things will get cancelled, then you will get dimensionless, no dimension. Everything will get cancelled, no dimensions. Okay. Now 101 is power of lens. Power of lens. Power of lens is actually 1 by focal length. Okay, focal length. So it's a length only 1 by L actually. It means L raised to minus 1. Okay. Now 102. 102 is magnification. Magnification means it's a ratio. Okay, for the same quantity. So this is no dimension for this. Okay. Magnification will not have any dimension. No dimension. Now 103. 103 is fluid flow rate. Volumetric fluid flow rate. Okay. What is volumetric fluid flow rate? Is equal to volume by time. It's equal to L cube T raised to minus 1. Now 104. Fluid flow rate, mass flow rate. Mass flow rate. It's equal to mass flow rate is mass per time. Okay. It's equal to M T raised to minus 1. Now 105 is electric field. Electric field is equal to electric force by charge. Okay, what is electric force? M. Force is actually M square T raised to minus 2. Charge is A into T. Okay. It's equal to M L square T raised to minus 3 A raised to minus 1. Okay. Next is 106. 106 actually dipole moment. Electric dipole moment. Dipole moment. What is electrical dipole moment? Electric dipole moment is energy by electric field or torque by electric field. Okay. So torque we know, torque is actually M L square T raised to minus 2 is energy only. Electric field. Electric field just now we calculated M L square T raised to minus 3 A raised to minus 1. Okay. Okay, so M and M will get cancelled. L square will get cancelled. So what we will get ultimately we are getting T raised to minus 2 into plus into T raised to minus T raised to plus 3. When T raised to minus 3 is moving up, it will be T raised to plus 3, then it will be T. Okay, then A raised to minus will be A. So it will be A into T. 1 second, let me check. Now there is one L also is left. This is actually L square. M L square T raised to minus A. Then torque divided by electric field. Torque is M L square T raised to minus 2. Then electric field is actually M L square T raised to minus 3 A raised to minus 1. So ML square T raised to minus 2 ML T raised to minus 3 A raised to minus 1. Electric field. Yeah. Electric field is it's actually there's a small mistake we made here. Electric field is actually this not ML square. Force is actually ML T raised to minus 2. Therefore, it will be ML T raised to minus 3. Okay. Electric field is ML T raised to minus 3 A raised to minus 1. Therefore, electric dipole moment is actually there's no L square, is only L. Okay. So there is one L raised to minus 1 also is there. So then one. Okay. Now this is the torque is correct here. Here actually this only one L is there. Electric field only one L is there. Therefore, it is actually L square here. This only one L will get cancelled. Okay, the one L is already there. Therefore, it's L into T into A. Okay, it will be LTA. Okay. Next one 107. 107 is electric field strength. Electric field strength or electric intensity. Electric intensity. What is electric intensity? Electric field strength is actually potential difference divided by distance, or work done per charge. Okay, work done per charge per distance. So it is work done divided by charge. Okay, that is potential difference. Potential difference is nothing but work done. Okay, voltage is work done by charge. Okay, divided by distance. Work done is equal to m L square T raised to minus 2. Okay, and charge is equal to A into T. Okay, and the distance is equal to L. Okay, so M, L and L will get cancelled. ML T raised to minus 3, A raised to minus 1. Okay. ML T raised to minus 3, A raised to minus 1. Okay, correct. Now next one is 108. Is electric flux. Electric flux is electric field into area. So the electric field we have already calculated. It is ML T raised to minus 3 A raised to minus 1 into L square. Already we have calculated. Okay, electric flux. That's a electric field. Therefore it will be M L cube T raised to minus 3 A raised to minus 1. Now 109 is magnetic flux. What is magnetic flux? Magnetic field into area. Okay. Sorry, 109 is not magnetic flux, it's magnetic field. Sorry, magnetic field or flux density is equal to force divided by current into length. Okay, force we know ML T raised to minus 2 divided by current is A, length is L. Okay, so what will get? Magnetic flux is equal to M. This both L will get cancelled, then M T raised to minus 2, A raised to minus 1. Okay, this is actually magnetic field. Magnetic field. Now 110. 110 is magnetic flux. Magnetic flux is equal to magnetic field into area. Field MT raised to minus 2, A raised to minus 1 into area L square. That is M L square raised to minus 2, A raised to minus 1. So 111 is inductance. We have already calculated inductance. Okay, this will be repeating. So 112 is magnetic dipole moment. Magnetic dipole moment. Okay, magnetic dipole moment is torque divided by magnetic field. Magnetic field is equal to torque is we know its energy ml square T raised to minus 2 divided by magnetic field we know we have calculated mt square A raised to minus 1. Okay, so we will get L square A. Now 113 is magnetic field strength, magnetic intensity. Okay, or magnetic field strength or magnetic moment density. Okay, that is magnetic moment, magnetic dipole moment divided by volume. So what is mandatory dipole moment? L square A. Just now we have calculated, divided by volume is L cube. Okay, therefore we will get L raised to minus 1 A. Okay. Now 114 is capacitive reactance XC. Capacitive reactance XC. That is 1 by omega C. So 1 by omega C. So we know that 1 by omega is actually T raised to minus 1. Okay. Into C. C is actually M raised to minus 1. L raised to minus 2. Then T raised to 4 A square. Okay. So what you will get? You will get actually M L square T raised to minus 3 A raised to minus 2. Okay. Next 115. This capacitive reactance. 115 is inductive reactance XL. XL is equal to omega L. Okay. Mean angular frequency inductance. So angular frequency, what is angular frequency? T raised to minus 1. Okay. Into inductance. Inductance, what is inductance? Inductance is actually ml square T square is equal to M L square T raised to minus 2. Sorry, it is actually ml square T raised to minus 2 A raised to minus 2. Okay. So ml square T raised to minus 3 A raised to minus 2. Okay. Now 116. 116 is velocity gradient. Velocity gradient. What is velocity gradient? Velocity gradient is velocity by distance. Velocity by distance. That is LT raised to minus 1 by L. It is T raised to minus 1. 117 is pressure gradient. Pressure gradient. That is pressure by distance. Pressure by distance. Is equal to force by area by distance. That is ml T raised to minus 2 by L cube. That is actually M L raised to minus 2 T raised to minus 2. Then 118 is pressure energy. It's equal to pressure into volume. It's equal to M ml minus 2 M L raised to minus 1 T raised to minus 2 into L cube. It's equal to M L square T raised to minus 2. 119 is trigonometric ratios. Trigonometric ratios, we know all trigonometric ratios are ratios of length. Therefore, it is dimensionless. All sin theta, cos theta, tan theta, all the ratio of two lengths. So it will be dimensionless. Now let us see the dimensions in mechanics. In mechanics, all the physical quantities can be written in terms of the dimensions L, M, and T. Mechanics is a fundamental branch of physics that deals with the motion of physical objects and the forces that cause or affect the motion. It investigates how bodies behave when subjected to forces of displacement and the subsequent effects they have on their surroundings. Essentially, mechanics seeks to understand and predict why objects move or what causes motion and how objects move or the description of the motion and the condition under which the objects remain at rest or at equilibrium. So in SI units, force will have the unit of kilogram meter per second square. And F is equal to MA and the dimensions is M1 L1 T raised to minus 2. Similarly, weight is equal to W is equal to mg and the SI unit is Newton and the dimensional formula is M1 L1 T raised to minus 2. Work and energy, kinetic energy, potential energy all have the same dimensions and the SI unit is Joule. So it will give M1 L square T raised to minus 2 dimension formula. Then pressure will be in Pascal, then which will give M1 L raised to minus 1 T raised to minus 2. Momentum is equal to mass into velocity and it will be M1 L1 T raised to minus 1. Impulse is force into time, that is M1 L1 T raised to minus 1. Velocity we know it is actually LT raised to minus 1 and acceleration is LT raised to minus 2. Density is mass per volume, mean volumetric density. It will give M1 M raised to 1 L raised to minus 3. So strain is dimensionless, being a ratio of two lengths. Stress is M1 L raised to minus 1 T raised to minus 2. Young's modulus, the unit is Pascal and the dimensional formula is M1 L raised to minus 1 T raised to minus 2. Torque is nothing but work and the dimensional formula is M1 L square T raised to minus 2. Now let us see the group of physical quantities having the same dimensional formula. And length, distance, displacement, radius, then light year, parsec, then astronomical unit AU, wavelength, radius of gyration, everything will have the dimension of length, which is nothing but L. Then speed, velocity, average speed, terminal velocity, critical velocity, speed of light, escape velocity, orbital velocity, velocity of reflex, instantaneous velocity, relative velocity, uniform velocity, drift velocity, wave speed, everything will have the dimensions of velocities or speed, which is LT raised to minus 1. Momentum, impulse, both having the same dimension, M1 T raised to minus 1. Frequency, angular frequency, decay constant will have T raised to minus 1. Then acceleration, centripetal acceleration, tangential acceleration, retardation, average acceleration, instantaneous acceleration, acceleration due to gravity, centrifugal acceleration, relative acceleration, everything will have LT raised to minus 1. Then force, weight, tension, centripetal force, tangential force, frictional force, tensional force, then normal reaction force, spring force, pseudo force, viscous force, gravitational force, thrust, magnetic force, conservative force, non-conservative force, buoyant force, everything will have the dimensions of force, which is nothing but MLT raised to minus 2. Then work, heat, energy, kinetic energy, potential energy, thermal energy, light energy, torque or couple, then moment of force, everything will have ML square T raised to minus 2. Stress, pressure, then modulus of velocity, Young's modulus, bulk modulus, then modulus of rigidity, shear modulus, then energy density, everything will have ML raised to minus 1 T raised to minus 2. Angular momentum, momentum will have ML square T raised to minus 2. Let us now see some dimensionless quantities. Dimensionless means actually M raised to 0, L raised to 0, T raised to 0. Then refractive index, for example, since refractive index is a ratio of velocity of light and the velocity of light through a vacuum and through the medium, then since it's a ratio, it has no dimensions. Then strain is actually the ratio of lengths, therefore it is unitless and it is having no dimensions. Relative density is the ratio of densities of two substances and it will not have any dimension. The coefficient of friction is the frictional force by normal force, therefore the ratio of two forces, therefore no dimensions. Relative permittivity is the ratio of two permittivities, therefore there is no dimension. Okay, same as the case of relative permeability. Position ratio is actually lateral strain by longitudinal strain because it is the ratio of two strains and hence it is dimensionless. Specific gravity is the density of substance by density of water, therefore it will not have any dimension. Angle, we know it is actually the ratio of two lengths. Okay, it is the arc length by radius. therefore it will not have any dimension. Same is the case for steradian. Efficiency is actually the ratio of similar quantities, two similar quantities, therefore it will not have any dimension. With this, we have almost covered all the theory part of the units and dimensions for the 11th standard physics. Okay. Now in the next part, we will be covering the numerical problems as well as the MCQs. Thank you.